I've got a panel conversation to do next, and I get to participate to some degree. So come with me as we come sit with Mikayla Hutchinson, Damian Edwards, and David Fowler, real architects in software. Not like me, I'm just a professional storyteller, but somebody has to manage these folks, and I'm going to be able to take your questions directly on the board here as well, so we'll be able to keep going. Let's kick this thing off, guys.
Awesome.
How do you get to designing language features? Like, we just saw Jared walk through a great piece, one particular case, but how much of this is internal inspiration versus what your customers are asking for?
It's a bit of both, I think.
Mm-hmm.
It's a bit of both. Like, for example, during .NET 6, we worked fairly closely on the ASP.NET Core features to do with minimal APIs. And the desired outcome for the coding experience that we wanted for our customers with regards to like what code you actually write in the CS file in the first 15 minutes of using ASP.NET Core, we were hitting some aesthetic issues. We was like, well, we don't want the code to look like that. We want it to look like this. And then the reasons it didn't look like that today were due to language design things. And so we worked with the language team to drive those changes through. So that's one example. Then obviously there are examples where people log issues on GitHub or wherever it might be.
So, and I mean, I'm aware, so we've talked about this on .NET Rocks at times too. It's like the issues that come into GitHub, that is your meeting, right? Like that's part of your whole conversation about design for everything.
Every week we triage with the whole team, all the issues. We sit around as a team, we sit in the room, we go over every issue, and we decide what we need to put as feedback for every issue. So what's funny about designing like, features and language design features are, we wanted the code to look a certain way. That seems very easy from the onset, but to actually change the language to get that code to be written is insane. Like we had to fix issues in overload
resolution,
mm-hmm. and we had to fix a couple more things like that. It was very difficult to actually get the changes in to make the code look good. And for us, it was like, let's just make the code look like X. That was
so
a
you
big
sort of drew
issue.
that on the
we
board.
Drew on the board.
It should be
that
expressed
was a
like
vision,
this.
But it was like, then Jared was like, we're gonna have to change this and that and this has to gel with that feature and this other feature. And we were like, okay, but in the end, we want this.
It's probably like working with an interior designer.
Oh, yeah.
And the customer is like, well, I want the wall to be this color. And then the interior designer is like, I don't think you understand all the things that have to happen for that to actually work. And I'm not a language wonk by any stretch of the imagination. So it's a very, it's quite an in-depth learning experience when you say, but why can't it just look like this? And then the 400 things that hold about why.
And of course, on one hand, I feel like, are we really that focused on aesthetic? Is that important? But I'm all for readability of code. Is that really what you come down to? Is like, when I look at this, this means what I think it means?
Yeah. A big part of it is syntax. Like one of the big things that we can do is paper over runtime group with syntax. So the language can let me do var f equals some function. Mm-hmm. And for that to work, the language has to infer like 10 things, but the end experience is that f infers the type of function that's being written. And It looks great. And if you didn't know the language design, you would think that would work to begin with. Because like, why couldn't the language infer? I'm telling it the arguments, the return type. Why is that hard to do?
Yeah.
And then you dig into the actual design and you sit in the room with these people that built the compiler and you understand. You're like, okay, whoa. Okay, that case, okay, this case, okay, generics, okay, open, close generics, object, delegate, like which one wins? So it is really complicated.
Yeah, it's a plumbing kind of
It's
problem.
Plumbing, yeah.
It's like, it looks like a faucet on the top, but wait till you get under the cap. There's all kinds of things going on down there.
Yep.
Yeah, I'm a huge fan of things doing what you expect them to do, but that's partly about setting expectations and partly about staying true to expectations. So once people get a sense of how it works, they can actually trust that. So every decision you make, you have to evaluate whether it's breaking those promises you've made.
I love that point, Mikayla, too, because you're also talking about changing code I already have working, right? When you talk about changing that view, you are talking about, it's quite possible that I'm going to fire it up with the new compiler and it's actually laid out differently. Like, am I happy? Do I recognize my own code anymore?
Yeah.
The big thing is going from a thing that was an error to a thing that now works.
That is not an error.
Yeah.
We actually changed a bunch of that stuff in .NET in C# 10, I think. Mm-hmm. And there's a big debate, like, do we want when people recompile their libraries that they get this new behavior change? And I think we actually went over and compiled a bunch of code on GitHub, and we found a couple of cases that were like, this library would break if we made this change. And then we have to make a call, like, do we want to make that change? Is it going to be opt-in? Is it going to be a warning? So yeah.
And the longer the language has been around, the more code there is in that language,
Sure.
the harder it is to make those type of changes because you have to consider so many more cases.
Finger in wind. How many people are using this feature? No one is.
Yeah.
First preview, you broke my library.
Yeah, everybody is. Yeah. Well, and it is always that great debate about you're not necessarily your customer, right? I mean, even though C# is used extensively inside of Microsoft,
Yep.
you're definitely going to bump into folks who use your languages and your tooling different. And I think that brings up a really powerful question. Like, .NET is one thing. It is not just C#. There are other languages. There are the base class libraries. There are the APIs, and there's the runtime. How often does the conversation get into about how do we get this feature? Where should it live?
Yes, absolutely. And then even with the context of the runtime or the base class library, there are layers within that as well. In today's modern .NET world, we have we have the BCL, which is the system.star, typically the stuff that ships in one of the runtimes. And then we have Microsoft.extensions, which is a set of BCL extensions, which it's hard to kind of explain the delineation there about.
I would say dependency injection-based libraries that live in the BCL are kind of that extension-based.
That's fair. That's fair.
Lineage.
And it's stuff that it admittedly started with the development of DNX and ASP.NET Core, and then has moved into sort of its own island that gets reused among a couple different app models since. And then obviously we have the app frameworks on top of that. We have the WinForms and WPF, the existing ones, and then we have ASP.NET Core and other frameworks. And so when it comes down to like where does this live,
right?
And whether do we utilize say the runtimes type system, or do we utilize language features in order to allow expressiveness and to build constructs that people can then build their apps on top of? We debate this stuff all the time. Like, should this be a base class that you inherit from? Should it be an interface that you implement? Or should it just be a language feature that you utilize in order to take advantage of this mechanic? And that's, as sort of designers, something that we do quite often.
And there's not one right answer, right? Like
No.
many of these things could have been implemented any of those ways.
Absolutely.
Or do you put it in all the places?
Yeah.
Do you rate limit HTTP client and pipelines and streams? And do you do it in ASP.NET Core? So for rate limiting, we actually put it in the BCL, the core abstraction, the core implementation, and then we built stuff on top in the BCL, in ASP.NET Core to rate limit requests. So we decided that feature was super generic and can be used for more than just HTTP. So we split it in two and broke it into like core, implementation, and abstraction in the BCL, and then a feature in ASP.NET Core to rate limit incoming requests. So that's pretty awesome.
Mikayla is newer to the architect team. Like, I've talked to you guys for 10 plus years. I think, Mikayla, we first talked back in the Xamarin days?
Yeah, it's been a while. Yeah, I came up from the Xamarin team. I was originally a dev, then became a PM, then kind of ended up in the middle, which is really what an architect is.
You used to have a real job. How'd you end up running with these guys? Like, honestly, why choose to be an architect in this scenario? And I'm just thinking you bring particular experiences to the table for the architects too.
Yeah, so my area of focus is tools. I recently ended up on the tools team, and I'm very happy about that because tools is always an interest I've had about making these tools that help people build things easier. And I like to think very holistically. Like, I'm one of those people who, when you try and build something, tells you all of the other things you're going to break when you build it that way. I like to focus on how we solve those problems, not just give you the problems, but I like things to be consistent and make sure that we can set those expectations for people and make sure that it works for as many people as possible. And being an architect is really the place to be doing that.
Yeah, no, it's an interesting locus of you're also making decisions that are going to impact people for a really long time. So it doesn't come with a light burden. Related to that, let me grab this question from Dimitri, who said, who decided that minimal API is aesthetically pleasing at all? Because I think there's an interesting question here about what is the aesthetic.
Right.
And then you throw in the word minimal, because that's a kind of aesthetic right up front.
Yeah. I mean, there's an interesting history there. One thing we haven't talked about, which I was going to mention as part of language design, is we can't ignore the ecosystem, the competitive landscape. Like, obviously, we sometimes have to react or we sometimes take influence from changes that we see happening in the wider programming language
competitors,
or software development industry. And one thing that was fairly apparent was that when looking at the experience of very new developers, building APIs, which is a very common thing for new developers to be building these days. Everyone builds APIs. Even if you're building a front-end app, you build an API for it to be called. That when you compared some of the more modern frameworks that really focused on we are for building APIs, and you compared to what that looked like in the first sort of 15 minutes, compared to what it looked like to use something like ASP.NET Core in the first 15 minutes, there were some differences. And then on top of that, there were some other forces, like we wanted to make MVC faster, but we had kind of hit the limit about how much more we could take out of MVC without impacting what makes MVC MVC.
Right.
And so those kind of two things together led to Fowler and some others doing some investigations, right?
Yeah, so we started a project called Feather HDP, and the goal was to talk to non.NET customers and give them a tutorial where they have to write a React front end and a C# back end. No ASP.NET Core, no names, just C#. And they all had a preconception of .NET being old and crusty and for the enterprise. And by the end of every interview, we did like Go, Python, these devs, and they felt like it was JavaScript. And that was the first so mostly people don't even know about modern C# and how it looks, how it works, how it does feel like other frameworks. And that led into kind of a functional approach. I think in general, there are kind of two approaches to doing web APIs. If you look anywhere, like Node, Go, Java, there's two styles. There's a class-based approach where you have a top-level class like a controller, and it has methods that are routed to by attributes or some declarative means to declare a route. And then I have a function, and I have the function maps from a route to a function, right? And those were basically the two styles that were out there, right? And we kind of dipped our toes in the other style. I think Damian did it in 2.1. You can call map get, map post, map put.
Felt like I had a big argument about that.
No one knows, right? It's not we kind of didn't say it was a big thing, but it was a thing that was there for a long time. And minimal APIs was the first time we were trying to say, okay, let's embrace this functional approach and just kind of support direct to, I think we call it route to code. That was the internal code name. Could we make it more direct to route to code? No classes, less indirection. I could just close over state and just write functions, right? Because it's more simpler, it's direct. You can see it all in one place. And how do we simplify startup, program, app settings? There's file new project is super useful, but it has 4 or 5 files. And then you add a controller in a different folder. So you have to go find that class. So how do we start new developers who have never used .NET? How do they find their function? How do they understand by looking at the code that / will return hello world? And minimal APIs came out of I think me and Damian sat down and we started from the Feather code base, and we drew out the end goal. We wrote a to-do app with EF, and I think that was it.
Yeah, in Markdown.
And SQLite, in Markdown, in a gist.
In a real file.
It's still there in a gist. And we said, okay, we need to change the framework, languages, and tools to get this endpoint. And every preview, we would check to see how close we were to that end goal. So we changed EF APIs, we changed the language, we changed ASP.NET Core, and every preview, we would go, how close are we now to this end state? And is the end state still good? Right. So that was how we kind of push ourselves past our typical design principles to get to this end goal.
It's always my fear with simplification like that is then as complexity gets added to the app, as the feature set as we go deeper into what we actually need to do, are you managing that complexity well too? Because the actual functional parts of the app are going to be complicated.
Well, there's that, and there's also the tooling aspect. And that, a lot of that structure or that ceremony, there's a word that comes up a lot when we talk about minimal, is the lack of ceremony. A lot of that ceremony that exists is not only useful with regards to creating structure for your app, which helps understanding, it helps organization, but it also can create structure for tooling to attach to and tooling to leverage in order to make your code more dry or make it easy to find things. So I know, Mikayla from the tooling side obviously focuses on those types of aspects more than we might, 100% of the time, but we had to take that in consideration as well, which is okay, if we're going to remove a lot of this structure, towards this goal, what does that mean for all of these great tooling features that exist today? How is tooling going to allow someone to navigate from here to there, or to do this type of refactoring, whatever it might be? Or what type of new tooling innovations can we create when people are going to be working with this style of application rather than this style of application? Right. So there's always a bit of a cycle, I think, between runtime, framework, and language design and the tooling design. And obviously with the language team, Jared was just up, they work very closely with the tooling team. In fact, they have basically together, the C# tooling and language team are basically part of the same unit. So they have to think about it a lot. And on the framework level, we have a little bit more distance between us and the tooling, but we definitely think about that a lot.
Yeah, because I got to think, if you don't put tooling around a feature like that, people aren't going to use it. Like ultimately, do the squiggly show up in the right places? Does it become a refactoring option? Like, how do I learn about this new feature?
Right.
So very controversial. We changed the template in .NET 6 to start with the new minimal ceremony, like that template. And that discussion internally was, and Damian made the change. So if you want to blame someone, blame him. But the discussion we had internally about how do we get people to see this feature, to even know that it exists, right? So a brand new customer comes to our platform, they do .NET New API or web, and they see the startup class and program and like the 4 files, and it's more complicated. How would they ever find this other way?
Right.
That we want to be the primary way that new developers find this tooling. And this comes to a problem where we have a lot of different customer cohorts. We have like enterprise developers who are like bread and butter. And then we're trying to get these new developers that wouldn't otherwise look at our stack.
Right.
And how do we like trade off what to put front and center with those two cohorts of customers? Right?
So you're never going to take a feature away.
Right, exactly. Exactly.
Because people's code depends on it.
Yep.
But
yeah, I like to think in terms of off-ramps, like when you have the fast way and you have maybe a more complex side underneath that lets you have more flexibility and do more. Like, how do you let people get, like, once they hit the limits, once they realize that maybe for their use case, the fast, simplified way doesn't quite do what they need to do, how can they find their way off? Like, you don't want them to just like go straight off the side of the overpass. You want them to have a nice ramp down, and tooling is a big part of that. Right? Whether it's tooling that helps you discover those other features, or tooling that helps you transform your code, or there's all sorts of things.
Because I think there's two, the greenfield, brownfield scenario is very different there. The new person coming in greenfield is going to use the new language features, especially if the tools put them front and center. But how much push do you have on brownfield to say, you're using a C#2 kind of approach to this. We got C#11 here. Let me show you the refactorings of that.
Yeah, it's not really terminology we use, but I guess that is a natural mirror to off-ramps, which is on-ramps. How do you get people onto the more readable, smoother, simplified way if it is the better solution for them? How do you help them take advantage of these more modern approaches and more modern features? And refactorings are a huge part of that, and analyzers. There's only so much scope those have, though. Those aren't going to help you currently with your project files or, yeah.
And that, Menren asked this question specifically at Roslyn. So much of this new magic is part of Roslyn. I remember talking to Mads back in the day saying, I'm feeling like we're about to have a Cambrian explosion with the open sourcing and the compiler as a service mindset and so forth. But how much does it affect how you do tooling today? Like, you now have those analyzers. You have the ability for C# to analyze itself a lot. Like, how much does that shape both the frameworks and the tools?
A lot, actually. It's interesting that there was a running meme inside the team that I'm on, which is every time we say, we'll just fix that with an analyzer, I usually retort and say, great, that means we'll never fix it.
Yeah.
And that's mostly just because we have to build the muscle to write the analyzers.
Right.
And analyzers are not a solution to all problems. There are so many, as I mentioned before, there are things that we can express using language constructs. There are things that we can express using the type system and runtime features, which obviously are tied to language constructs, but they are separate and distinct concepts. And then there are things that we can express and enforce using framework constructs or app level framework constructs, the things that we have there. And sometimes when we can't express something in a language construct, we might be able to enforce it with an analyzer. So rather than saying you must implement this interface, we may say, well, we'll detect when you're doing something that we can't protect against with a language construct by creating an analyzer instead.
Right.
But we need to build up that muscle so that the team that builds ASP.NET Core builds the analyzers for ASP.NET Core. And that's something we've been working on a lot at the moment.
And are those things just going to run automatically, or do we actually have to convince the users to use those analyzers?
Well, that really speaks to Mikayla's point about on-ramps and
Yes.
off-ramps, about how do we get those people to use those things?
Well, and some people look at the new editor and the way that code gets decorated with all of these tools and say that's noise, not information. I mean, I know the difference between a red squiggle and a blue squiggle, but it really gets into the various pop-ups, arrows, like when do you know you need to do or there's an opportunity for refactoring. And this, falls pretty clearly to Mikayla. It's a tooling thing.
Yeah. Well, that's a very valid perspective. A lot of the things that analyzers suggest that you might do are a matter of personal choice or aesthetics and so on. So it is important that we have tools to suppress them or to change the severity of particular analyzers in your editor config file. So that is something that tooling does give you. But yeah, it can be very overwhelming if you open up a file and it's just all squiggles.
All we know for sure is all your code is wrong.
Yeah.
That's what we know.
Yeah, and there's also big differences between the different kinds of experience as well. Like if you're writing code and you see a squiggle in the code you're writing, like that's very different than you do a build and you have like 10,000 analyzer warnings because it's run over your entire code base. And the first, like, the squiggles maybe don't seem quite so intrusive because they're more maybe approachable. But when you have the bigger, like we do have code cleanup tools that help you fix whole swathes of analyzers, but that can be fairly difficult to review. So there's always trade-offs, and yeah, everything's trade-offs.
Nothing comes for free. Otherwise, you would have done it automatically, right? I mean,
and even analyzers. Yeah, like there are limits on the analyzers we can build. Like there are some analyzers we would like to build, but we just can't because they're too expensive computationally, that we just can't run them in the background, or there's only so many we can afford to run.
Yeah, I could see analyzer propagation becoming a huge issue, especially when the cop-out solution is just make it an analyzer.
Yeah, and then an extension of analyzers that we talk about, Mikayla mentioned refactorings, which are generally manually invoked by the user, so they're not so bad. But we also have source generators, which is a fairly new thing, but they run while you're coding. They have to run while you're coding because they actually generate code in your app. And so at some point, performance becomes a consideration. We can't, and Mikayla just hit it on the head. It's like being an architect and designing any of these features is about trade-offs. It's literally the number one principle. You are never going to be able to make everything perfect. You are always trading off some part of the developer experience, some performance, some aspect of how accurate what you're showing is and at what point in the development lifecycle you're seeing it, against all the other things. And so a lot of our job is arguing about what is the right trade-off to make this release.
Discussing
strongly.
Yes, with vigor.
With vigor. What the right trade-off is to make. And the equation changes from release to release. Sometimes, we get 3 or 4 versions away from when we made a particular trade-off, and we decide that was wrong now, it's wrong for today, so we make the other one.
Wrong, or just we didn't have the information.
Things have changed.
Sure, yeah. And I immediately think in terms of execution performance when I deploy this app versus the development experience performance. Because a lot of those analyzers and so forth, they're running at my dev space as well. Like how much is that impacting my dev cycling?
Right, and the variance in dev workstation performance is huge.
Yes.
Sorry, Mikayla.
We get so much feedback on performance of the developer experience because people get frustrated when they're writing code and things freeze up and they have to pause for a couple seconds. And there's the running joke about going and making a cup of coffee while your code's compiling. And hopefully that's not so much of an issue anymore. But if you invoke a refactoring and it takes 20 seconds, that's a real stall, and those kinds of paper cuts build up.
That's a great expression, a series of paper cuts.
I am worried that when we shift things from runtime to tooling time, it turns everyone into a compiler author. And I don't think everyone has let that sunk in yet. You're basically shifting time. So we think about using SourceGen to improve time at startup and runtime time for the actual app when it runs, but you're moving that time to build time. And I think that works well when you're doing 1 or 2 or 3 small things. When it's like 50, or every package decides to source generate everything because it's faster, then we're gonna have performance issues at build time, which we have already, right? But so I think those are things to think about as we're trying to move to this new world of having people write code for libraries and ones that run at build time.
And historically, we've had this difference between debug builds and release builds, which don't maybe mean as much as they used to. But I think there are definitely opportunities for thinking of the different kinds of inner loops and outer loops and so on. Of when you're writing code, you want to optimize for build performance, and when you're building your code to deploy, you want to optimize for runtime performance, and that's always been the case with C++ compilers and the different optimization levels and so on. And maybe that's something we need to be thinking about again as well, now that we have source generators doing a whole lot of work that's really targeted at runtime performance, not developer time.
Yeah, I think that's very fair. We got just a few minutes left. There's been a sort of a gestalt set of questions in Twitter, so I'm going to paraphrase them around open source libraries, open source projects. And let me throw in add-ins and things on the tooling space as well. Do you get into a conversation about should we just be using these open source libraries, or is this a language feature we should add, or there's an add-in that people seem to like? Should this be incorporated into the tool? What does that conversation even look like for you?
Trade-offs again.
Yeah.
we've been through, and we continue to go through a bit of a journey on that. Folks who have been with us through .NET Core 1 to about 3 may, if you were using ASP.NET Core apps, you kind of saw the result of a lot of that journey as well. We made
JSON.NET.
JSON.NET was one, but also the introduction of shared frameworks in .NET Core 3 forced us to make some decisions about where those lines exist and how we draw them. And so today, if you create an ASP.NET Core app, some of our templates include open source libraries as NuGet packages, as references.
Right.
We don't have other parties' open source in our shared frameworks. Currently, we used to, and we got rid of that to try and draw a line between the two. But like a lot of, as we said before, this is a trade-off between what different cohorts, I think Fowler said before, want in our community, and we continue to have that discussion.
Yeah, I think it's a constant balancing act. And also what the customer wants, whether those features make sense or not. I think about the ecosystem in Studio, Mikayla, and just all of the tooling that exists there already, versus what do you add? Do you have to have that conversation about is this stepping on an existing ecosystem member?
Yes, that's a very important conversation to have. I think historically there has been a tendency of customers to use the Microsoft blessed thing, and maybe some people don't want to use something unless there is such a thing, but we don't want to be suppressing the ecosystem, right? We want to have a super vibrant ecosystem, people building things and other people using those things and us using those things. So part of this is about expectations and historical baggage. Part of it's that we have these trade-offs of when we bring something into the default templates, it has certain expectations, and those are something that we can't necessarily put onto a third-party library. It's complicated. It's a lot of very difficult discussions.
Yeah, and not always easy choices, right? If it was simple, everybody would be doing it. And I appreciate all the work folks do around there. One last question here. This is from Joe Cuerva, who says, what is the state of green thread support in Dot? David's all excited.
Yeah.
So we built a working group. This is kind of built up over years of seeing people doing blocking on thread pool threads and the slow thread pool growth, and we made changes to that in .NET 6 and 7 to make it better. But the fundamental issue will always remain. The moment you have async and non-async methods, And the day somebody ever wants to do an async thing and a sync thing, there's issues. So we have this experiment going on where the runtime team is trying to implement a new primitive in the runtime called a green thread. The idea is that you can call any blocking API, and it will magically yield this runtime-based thread. So it's basically like threads, but in the runtime itself, not in the operating system. And it actually works. And I have a branch. It's actually all open source. For runtime, it's on the runtime lab repository. And then for ASP.NET Core, it's a branch. And it works. It's really slow right now. It's really slow. Don't try it. But it isn't crashing. So
that's
happy
cool.
about it.
That's awesome. Damian, Mikayla, David, thank you so much for this conversation. So much fun. I hope folks really appreciate it. And hey, if you get a sec, fill in that survey. The links are available there. Let us know if this is the kind of conversation you want to have. And with that, I'm going to pass this over to Dan Roth, who's talking a little bit about .NET's love of WebAssembly and .NET 7.